Homework 6 is on solving logarithmic equations. So there are two different types of logarithmic equations, and I gave you guys a step-by-step in the notes for each type. So type 1 is log equals log. So this whole front page is all log equals log. There are a couple on the back as well. So what you do, first step is you condense each log, getting it to the point where there's only one log on each side and there are no coefficients. So like this is the end goal, is you want it to look like this. Since number 1 is already set up like this, I want to pick one where you have to do a little bit of work first before it's in the right form. So let's look at number 3. So see how the right-hand side has two separate log expressions? That's where you need to bring in those properties that we talked about in the last homework set, where you're condensing two logs into just one log, and that's where you know you can move on to step 2. Okay, so if we look at the log on the left, log base 2 of 75, it's just one log, there's nothing out front, so this side is set and ready to go on to step 2. The right-hand side is not, because there are two separate logs that need to be simplified. So one of our properties from the other day says if you have two separate logs with addition in the middle, you combine them as one of a product. Okay, so left-hand side, not a change needs to be made there. The right-hand side, you're going to multiply those things together. So you're going to multiply 3 times 2y minus 1, which means you're going to FOIL, I'm sorry, not FOIL really, but distribute that 3. So 3 times 2y, and then 3 times negative 1. So that's the product property. If you've got two separate logs with addition in the middle, you combine them into a single log, and you multiply those insides together. So that's step 1. Condense each logarithm so each side is completely condensed. There's just a single log on each side. Step 2 says use the one-to-one property. And the one-to-one property says if the inside of the logs are equal, then you can just drop the log part and set the insides equal to each other. Okay, so we do that very similar to the exponential ones, where once the bases were the same, you were just able to drop the base. Here, you just have a single log with the same base, so you're able to drop that part as well and just set the insides equal to each other. And step 3, solve. Make sure to check for extraneous solutions. So here I'm going to add 3 to both sides of the equation. When I do that, I get 78 is equal to 6y, and then divide both sides of the equation by 6. And so 78 divided by 6 is 13, and that gives me my y by itself. Okay, so each one of these, you need to end up doing a check and simplifying your answer. So if I sub the 13 in, this is just log base 2 of 75. If I sub the 13 in here, 2 times 13 is 26, minus 1 is 25, and that's fine. Remember, logs cannot be negative. So you're only worried about if the inside expression came out to be negative. So here, this inside expression comes out to be 25, which is a positive number. So this answer checks out just fine. Okay, our second type, rather than log equals log, is log equals number. So we'll find one on the next page where we've got log equals a number. Okay, so let's look at number 12. All right, so step 1 for log equals number is to condense and isolate the logarithm. So here the logarithm doesn't need to be condensed because there is only one. Something like number 14, you need to condense that first. But the other part of this step is to isolate the logarithm. So to isolate it, I have to move this 15 over. So I'm going to subtract 15 from both sides of my equation. Oops, that's an 8, sorry. So subtract the 15 from 18, it leaves me with 3. And this is an 8, it's just not a very good one. That made it worse. Step 2, write the equation in exponential form. So this is the key difference from log equals log versus log equals number. And this is one that people mess up a lot. So there is no log on this side. A lot of people will just drop this and set this equal to 3, and that would be completely wrong. So step 2 is write the equation in exponential form. All right, so exponential form, the 8 is the base. This 3 on the other side here turns into your exponent, and then you set it equal to the expression that you have on the inside here, like that. All right, and then that just gets cleaned up and simplified as much as you can. So on the left-hand side, we have 8 raised to the 3rd power, which is 512. This is step 3 that we're doing right now, by the way. Solve, and then check for extraneous solutions. Okay, so I'm going to add 20 to both sides. So 512 plus 20 is 532 equals 28K. And then I'm going to divide 532 by 28, and that gives me 19. Okay, so check for extraneous solutions, which means subbing the 19 back in and just making sure that this expression comes out to be a positive one. So 28 times 19 minus 20, definitely a positive number. So this answer checks out and it is not extraneous.